We're going to look at polynomials, which as you can see is an extension topic. So recap of some of these ideas, because we have seen polynomials before. Start off with some basic definitions. What is a polynomial? So this is the form of a polynomial. We call it a polynomial of degree n, sometimes called the order n. It'll look like that. This is a technicality. Pn can't equal 0 because n is the term with the highest power, and so if Pn was 0, then x to the n wouldn't be there and it would no longer be the highest power. So it's trivial, but it's just part of the formal definition. This one's more important, of course. N has to be greater than or equal to 0. It also has to be an integer as well. Coefficients, well, no different to any other algebra. It's the thing in front of the x. Index, exponent, they're all words for the powers. Powers of the polynomials. As I say, we call it degree, could also call it order. It's whatever the highest index is, so we call it a polynomial of degree n. So a quadratic would be a polynomial of degree 2. Leading term, that's the term that has the highest power. Now make sure you read a question carefully and see what it's asking, because if it asks for leading coefficients, then the answer would just be Pn. Whereas leading term, it's the whole thing, the whole term, Pn x to the n. A monic polynomial is when the leading coefficient is 1. If we see polynomial equaling 0, well, I suppose it could be any other number, but normally we see equal 0, then we call it a polynomial equation, something to solve. Whereas when we see it equaling to another pronumeral, normally we'd see y, it becomes the polynomial function. Again, a trivial difference, but technically the equation is the one where we solve the problem, the function is the thing we graph. The roots are the solutions to the equation, so the x-intercepts if we were to look at the graph. The zeros, so we tend to call the x-intercepts the zeros rather than the roots, but they are the same thing. So the zeros are the value that makes the polynomial 0. Which of the following are polynomials? Make a decision in your head and let's see if we get it. Right, major decisions. Is the first one a polynomial? Someone said no, why not? Exactly. We said the power has to be an integer, and positive for that matter. So no good. What about B? Is that one a polynomial? Why not? I mean, we can't see it as a negative power, but if I was to rewrite it in index form, well, we'd have x squared plus 3 to the negative 1. I mean, we can't expand it out, but it would have a negative power. So that's no good. C, yes it is. You can have fractions in the coefficients, just not in the powers. So that's good. Not a problem there. Because you could rewrite it, a quarter x squared plus 3/4. But what about the number 7? Is it a polynomial? All constant numbers are polynomials because technically it's 7x to the power of 0, and we said 0 was allowed as one of the powers in a polynomial. Determine whether that is monic, and also what's its degree. Okay, have a look at that. See what you reckon. Is this going to be monic, and what is its degree? Hands for yes, it's monic. Hands for no, no it's not. Degree. What do we reckon? 3. Any others? Okay. What do we got? If you were to expand it out, yes, the x to the 4's end up cancelling. So, yep, it is a monic and it is a cubic. So, monic of degree 3. That's the first part of theory for today. So, our basic polynomial definition.